So take a look at the schedule. This week is week number 12. We're going to talk about how to visualize raster dataset. Last week we already covered how to do like vector dataset, GeoJSON, shapefile, something like that. And this we're going to cover another major one. It's about raster. So how to actually visualize raster dataset on the interactive map. And so hopefully we'll finish that today. On Thursday, we're going to cover how you actually build some interactive components, interactive widgets, so that you can change things interactively without having to do coding. Okay, basically you need to do coding, but you build your package so that your user don't have to do coding. Okay, this is about on Thursday. And after this week, you should have some like good idea about how things work in web mapping and vector data, raster data, using geospatial or open source approach. You should start thinking about what kind of things you want to build for your package, right? We have pretty much covered all the basics, how to build a package, how to bake some functionality. We also cover the basics about Python and how to handle vector data, raster data, and those are the building blocks for your Python package. And now you can start thinking about what you really want. Okay, so you need to build on top of this one to add some functionality. I'm not going to ask you specifically what you need to do each week. Now you should have the freedom to actually add whatever you want. If you have no idea what to do, look at the leaf map package, right? Essentially, this is the same thing that I use to build every day. Okay, so you have a website, you add functionality, and then you have a notebook. Look at what's out there and look at some of the functionality of the leaf map or Gmap and think about, can I borrow some of the features? You're welcome to copy the source code and to put into the package. As long as you can make things work, that's fine. So in terms of programming, geospatial, the best way to get started and to build is to learn from examples and know how to modify the example to integrate it into your own package to make things work. If you can do that, then you should be able to right now to build anything you want. Okay, so we have all the procedure, and today we're going to go through that one more time. They say, okay, I want to add some raster data, I want to visualize some raster data, I need some additional packages. How to actually approach that, how do we solve the problem, and then build into your package so that things can work. Just using a package, you don't need to learn other packages. Okay, so again, look at all the functionality in here. For example, leaf map. So far, we have only added like couple functions, but you're welcome to see what's already available in leaf map. See if there's any functionality that might be used for your package. You're welcome to use that. Of course, you can use leaf map as a dependency and then just use that. That's fine. But if you're just beginners, I'd rather show you from scratch. How do you approach it? How do you build on top of other packages? Because what we are trying to build here in this course is to build a mini version of leaf map. Okay, so right now you don't need to use leaf map as a dependency because it has pretty much done what we want to build. But I'm showing you how I build leaf map. Okay, showing you the workflow and the procedure and how to build functions, how to add the documentation. So make sure you go through that. Eventually, your your package should have all the components. You should have a website up and running. You have a GitHub repo. You have notebook examples. You can also have interactive map that people can try it out and you can look at this, right? Some of you already have this one working. This is basically about lab 7. Like if you add another module, leaf volume, how it makes things interactive on your documentation website. So again, if you have any questions, let me know or send to the email group. And today we're going to go through how to visualize raster dataset, because in geospatial, in GIS, basically you are handling two data types: vector data, raster data. Vector data pretty much can use GeoPandas to read most of the vector data format, and then in leaf map or in IPyLeaflet you can convert to GeoJSON and then display it on the map. Raster is different. Okay, so it might be a little bit tricky because it needs some other dependencies. So we're going to go through the steps today. Before we do that, if you go to the resources, I put some packages in here. We already covered some of those last time, like GeoJSON, GeoPandas. Today we're going to cover these 3 packages: Raster.io, local type server, and TiTiler. Has any of you heard about this package? One of those Raster IO actually pretty famous in the geospatial community. So GeoPandas is for vector data. Raster IO, sometimes people like Raster Real, whatever you want to call it, is for doing raster data. So convert the raster data into NumPy array, and then you can do all kind of geoprocessing. For most of the work we're going to do today, actually, we are not really dealing with data processing. We are more like how do we visualize the raster data set on the map. So nowadays, a lot of data in the cloud, so-called cloud optimized GeoTIFF. There's a very important data format that you need to know. So if there's some data in the cloud, you can actually visualize the data in the cloud without having to download it. One analogy is just like you're watching movie on Netflix, right? You don't actually download the movie to your computer. Think about it. It's like very high definition. It may be many gigabytes. You don't download it. You just stream the movie using a browser. So we're going to do the same thing here today. How to stream the raster data to your browser. How to visualize raster data without having to download it. So that's the beauty about open source cloud optimized GeoTIFF and also spatial temporal asset catalog. Different can do all of that, but I'm going to show you how do you build things build from scratch, how to visualize that. And also there are two potential scenarios you need to handle. Number one, the data is in the cloud. How do I visualize the data on the map? Also, the data can be on your local computer. How do I visualize the data on the local computer? So those are the two scenarios. We're going to cover the first one. How do you visualize the raster data set from the cloud? So the user only provide the URL, and then they can pull the data into your map, and then they can visualize, they can zoom in, they can zoom out. They can also interact with the data if you want to. But today we're just going to focus on visualizing the raster data set. Make sense? So next, I'm going to show you an example. Again, there are two packages you're going to use. The first one, they're called local type server. That one is for visualizing dataset on your local computer. The second one is called TiTiler. This one is for visualizing data in the cloud. And this is a pretty new project. It's probably maybe 2 to 3 years. So it's pretty new, but it has a lot of functionality allow you to visualize dataset. And you don't actually have to build the package. We can just use the so-called the API, and then we'll be able to pull the data onto the map. It might be a little bit confusing, but this is basically TiTiler. You can think about it's just like a middleman. You have data in the cloud. This middleman is just going to process the imagery, and then it's going to generate a URL, and then you can use the URL to add to the map. So if you remember last time when we talked about how to add a base map, how to add a tile layer, right? All you need is just a URL, right? So this TiTiler is going to help you generate the URL, so they can use the URL to plot the data onto the map. So it's kind of like a middleman. You think about they have so-called endpoint. Basically, you can think about a server, and then the server is going to run the data, generate the URL for you. Okay. And TiTiler already has a lot of good examples. I'm just going to show you just one example, and then we're going to reproduce the example, integrate the functionality into your package. So what you need to do, go to the TiTiler website. Again, if you're the first time here, click the link here, TiTiler, and then click this one here, examples, use TiTiler endpoints. Then click the first one, work with COG. Okay, so for those of you who have never heard about COG, it stands for Cloud Optimized GeoTIFF. It's the same GeoTIFF format, but right now basically it's optimized so that essentially within the GeoTIFF file, you have like some file structure allows you to request the data on the fly. So in the past, if you're using GeoTIFF, you have to download data to your computer and then maybe open using ArcGIS Pro, but now you don't have to. So think about you are streaming the data. It depends on the user, the zoom level. Depends on the area. It's just going to request the data for a small piece of the data. It doesn't need to request the whole data set. So think about if you have a raster data set that's like 2 GB. You don't need to download the 2 GB. When you are showing the full map, you only maybe very close resolution, maybe only 2 MB. Think about Google Earth. Okay, you just visualize the satellite imagery. Google Earth itself, the database is huge. It's many petabytes. but it looks so fast, right? When you zoom in, zoom out, it's render pretty quickly. It's kind of same idea in here. So when you zoom in, if it is zoom out, you use a close resolution. When you zoom in, it only a very small area. You don't need the entire data set. So that makes it really fast to streaming. And so in this example, I'm going to show you how you can actually utilize this to display the raster data set in your map. So first, let's download this notebook example and let's just try it out on a local computer, see if it works. And then once it works fine, then we can integrate it into our package. Okay, so click the download icon. To download this one to your package, I can just put it into my package and documentation examples. Then save it. With that, now I can open this one within Visual Studio Code and let's test it, see how it works. Okay, so examples, work with Cloud Optimized GeoTIFF. Anytime when you download a notebook from the internet and then try to run it on a computer, so make sure that you know what dependencies are required to run this notebook. So you certainly can see in this notebook it's pretty clear. It needs the volume. It also needs the HTTPX. Okay, so you can also use the request, the built-in library. But if you need to use this one, so when I hover my mouse, you see here there's a curly yellow line. That means the package is not available in this environment, so you have to install it. What we can do, you can open your Anaconda prompt or your terminal. Oops. Okay, so make sure that you install the dependencies, and later we can decide whether we want to increase dependency in your package or not. For now, we're just installing so that you can run this notebook on our local computer. Makes sense? It's different from like you are including this one as a dependency into a requirement.txt. You don't necessarily need that, and this is really necessary. So for now, I'm just going to contact activate GGOS or GO, probably GOS. Okay, then just pip install HTTPX. And then you finish. So this is a pretty small package, so it should be pretty quick. All done. Now we have this package. So what we need to do, you might need to reopen it so that now the package should be available. So click this one again. Okay, nice. Now it works fine. So last time, if you already installed Folium, so you should also have Folium on your within your contact environment. With that, you just run this one and then select the contact environment. So for TiTiler, it has a TiTiler endpoint. So this is basically a demo endpoint. You are certainly welcome to build your endpoint, but it's probably too complicated right now. For this lecture, we're just going to use this so-called demo endpoint. So think about a free middleman can help you handle some raster data and give you a URL. But you are welcome to have your own server. You have your own middleman if you want to. But for now, we're just going to use this one for simplification. Then this is going to file we want to visualize. If you go to the URL, you should be able to download the file. So this is the URL. This is from the Digital Globe Open Data. So they release a lot of high resolution imagery for natural disasters, and it's free. It's like I think 30 centimeter resolution, really high resolution. So this is the thing about this is the file you want to visualize. You're welcome to copy the link, and maybe you can go to the URL, just paste it, hit enter. It's able to download the file. So let me hit enter here. Okay, and I can download this one to my computer if you want to. But pay attention, this is a huge file. Not that huge. 307 megabytes. So think about it. It's pretty decent file size, right? And you probably don't want to use it if you have a software and then you have the file host on the internet. You don't want the user actually to download it. They can just request on the fly. Think about right now you're trying to watch this movie. It's better to just provide the browser. User go to the URL and then they can watch the movie. rather than download the entire file, because sometimes they just want to watch a small segment, right? There's no point downloading the file. But I'm just showing you that behind the scene, you have the file somewhere on the internet, and you want to pull the data on the map so they can see it. And this is what we're going to build here today. Okay, so the middle domain and the URL. Now let's take a look at this. So this is where it's actually reading the file, getting all the information. If you just run this one, oops, oh, TiTiler endpoint notified, so I didn't run this one, and then run this one. Can you see the results? Any issues? Good. Okay. So you see here, this one is getting the bounding box. This might look a little bit complicated, but essentially you can think about the middle domain has a server, and then this is so-called the endpoint. The endpoint means this is a cloud optimized GeoTIFF. It can help you read the file and then return the results to you. Okay. So right now it's basically returning the bounding box, the information about the bounding box. You can see here the minimum, the maximum zoom, the how many bands, and the band description, what data type. So this is kind of similar in ArcGIS. You open raster dataset, you right click, you see the properties, it will show you all kind of metadata information. So see in here, right now we are reading the data, the middle domain, the TiTiler endpoint, read the data in the cloud, and then get all the metadata information and then return to you. So you don't have to download the data. Although I downloaded it, but right now we are not using the file we downloaded. We are using the URL from the internet. Make sense? So this will help you return all the information. And so the next one here, you can also get the statistics. So for example, I run this one and take a look. So it's going to show you the B1, like band 1, band 2, whatever. And it's going to show you the minimum, the maximum, the mean, how many pixels, and also even a histogram, right? And pretty nice, right? This is only takes less than 1 second. If you download this file to your computer, you open using ArcGIS, it's going to take a couple seconds. You also need to have the hard drive, but now you're getting pretty much anything. Statistics, you're getting the bounding box, you're getting some information. This is what we need in order actually to visualize the data. Next piece, display types. So this is actually the central piece that we want is to visualize the raster dataset. So again, you probably don't need to do much. Just run the code. See that? Do you see the map? Nice, right? The image right now is visualized on here. So basically right now you are streaming the data from the cloud. So think about this is how it works for cloud optimized GeoTIFF. It only requests the data depends on your area, depends on zoom level. So right now what you are seeing in here, this small piece, the original data is 307 megabyte. But when it's actually retrieving, it's only maybe, I would say less than 1 megabyte. It's only resample into a very coarse resolution, and then only request that small piece, small tile. If you zoom in, you're going to see more and more detail. But think about the area become much smaller. So you don't need to request the entire 307 megabyte. This is essentially the same idea about Google Earth. You zoom in, you have the area is smaller, the data is going to be smaller. If you zoom out, the area is bigger, but the resolution is coarser. So you're also requesting on a small piece. So you can zoom in, take a look. This is very, very detailed, right? Very, very high resolution. You can zoom in. And also, if you see my mouse, when we pan the map, it's actually requesting a piece by piece and then putting it all together. So just like a bounding box, 256 by 256. You will see if I move my mouse very quickly, you will have some empty area, but you fill up very quickly. So take a look. See that? Do you see the bounding box? Pieces by pieces. This is called tile. So basically, it's a requesting. When you are zooming, zoom out, it's getting your coordinates of your map area, and then it's just going to request a piece. The piece depends on your area and also depends on zoom level. So this is how it's really fast. You are basically streaming the data, right? I'm moving here, moving up. You probably might be able to see. I'm not on your screen. You might be able to see the kind of the white outline. It's not perfectly. I'm not sure if you can see in here. At least on my screen, you will see the white line. basically a grid of white lines. And this essentially is subdividing the map into smaller pieces and then just request the pieces and then put them all together. Right, you're welcome to zoom out. And this is entire map in here. And all done, right? This is what we want to build. Because if you look at the source code, it looks quite, it's not like complicated, but at least for beginners, you probably have no idea like what this is doing. I just want to build a package that users just provide the URL and then map.add raster, for example, URL, boom, you have the map. So the user don't have to write this so many lines of code. Make sense? So what this one, the key things you need to get is actually this one. HTTPS get, and then you pass in the URL, and this is the URL to your raster dataset. Then you're going to get a JSON, and then within that JSON file, you're going to have the URL. So let me show you what this one is actually coming from. Let me copy this portion and create a new code block here. Just to show you the key things, how you get the URL, right? So I have the TiTiler endpoint, the middleman, and then the cloud optimized GeoTIFF, TiJSON.json, and then passing the URL to the raster. So see, take a look at this one. So I run this one, then I can just print out the R. Take a look at this. So the R basically is the request being returned. So what this one is doing here, the analogy will be like this. Okay, I have a map domain there trying to help me, and I just give my URL to the middleman. So this is what the middleman is actually doing. Okay, the URL to the raster, and then the middleman is going to give me this information. And the key piece you need to get is actually from here. TiTiler.xyz code tile, and then if you scroll down all the way to the end, it's a very long URL. And this is the URL that we need in order to visualize it on the map. Make sense? So let's go back to the package that we have built, right? So last time we already have the function allow us to, let me show you here. If we go back to the package, I should have a function called add tile layer. So if you remember, right, the URL, the name, and blah blah blah. So this URL is the tile URL. It's not the original TIFF URL. So remember, so basically the original one is just the direct URL. But now the middleman help us do something and then give us a tile URL. So we can use the tile URL to actually add that one to the map. So make sure you know the differences. And with that, we can come back to our package, see how we actually do that. So now we have this one. So next step, let's create a map using our own package and see how it works. So I'm going just to import GOS demo, right? And then we can create a map m.GOS demo dot map, and then map. Okay, we should have our own map. Now let's pull the URL back in. So how do you get to the URL here? Because the R only returns it like a dictionary, so we need to get the tiles key, and because this is a list of URL, so you only need the first one, right? So basically we are getting this URL. So what you need to do will be R and then tiles, then 0. Okay, so you run this one again, take a look. Now we save this URL. So this URL is the one that we need to build it, but you can assign this to a new variable. I say URL equal to this one. Then we have the URL. With that, take a look at this one here. So it'll be m.add tile layer, right? So this is the URL that we need. Okay, perfect. It's pretty intelligent. So map.tile layer, this is the function that we added last time, right? Now we just need a URL. We can give it a name, attribute if you attribution if you want. So run this one. Done. Where's the image? It's somewhere. The reason for that is not automatically zoomed to the area. So, but we can come back to this map, the example earlier, just to see where that one is actually located. Okay. So if I zoom out a little bit, it's somewhere. Where is it? Somewhere in Africa here, right? This island, and then here. Okay. So looks like here. Let's find it. See if if it shows up. So be somewhere here. Perfect. See that? Now you are basically streaming the data from the image using the tile URL, the middleman, the TiTiler generated for you, and then show on the map. Can you see the image? Again, like this is the tile JSON URL, and then you just get the tile, the first one, and then get this URL. After that, you can pass in a URL to the add tile layer function. Now you have this one. Okay. Anyone see the image on your map? No one? So let me show you one more time here, right? This is the example, the original example. So all you need basically just add a new line somewhere down here. I can, if you want, I can come here. Since we already get the result, you can simply just get the URL. You'll be URL equal to R tiles 0, and then print out the URL. Can you see this URL at least? Yes or no? R square brackets tiles and then square bracket 0. If you can see the URL, that means you can get the tile URL. This should be pretty simple. You just run the source code, get the URL. Done with this one? Yes? And then, so all you need is just import your package, create a map, and then map.add tile layer. You should be able to do that. So I'm going to do it one more time here. Why my screen is so dark? GOS demo, okay. And then m equal to GOS demo dot map. Right, create a map. You also have the add tile layer function if you follow my instructions last time, right? Add tile layer, and then just the URL, give a name, give an attribution, then you have the map, okay? So, but right now it's not automatically zooming to the locations here, but you should be able to see this one in here. Questions? Yes?
Mine is saying tiles is a key error.
Yeah, I'm getting it.
Key error?
Yeah.
So make sure you go back to you just run this one, run this display tiles section.
Yeah.
And then, oops. Oh, key error. So let me show you, just restart. Sometimes you mix up the variables, it might not work properly. So let's run this one again here. Restart the kernel and run the import. And the second one, the TiTiler endpoint. So the first two blocks. Okay, once you're there, come back to this one. Come to the display types example here. Run this one. Oops. Oh, and then you need another one. So you also need the get code info, maybe number 3 here, this one. And then go to the display tiles. It should work now, okay? And once you have that, just run this code block, get the URL. Basically run the examples, the code info, display tiles, and then just add this new block, R tiles number 0, and then print out the URL. Can you see the URL? No? Who can see the URL? Still no? 1, 2. Let me take a look. If it doesn't work, just re-download the notebook. Probably you change something messed up. Rerun that. You should be able to run just the entire notebook. And so make sure that you can get the URL. With the URL, then you should be able to add that to the map. So let me do it one more time just to show you what it is. Okay, if I'm having trouble, just follow me closely. Let me delete this one. Oops. Let me delete the notebook. Okay, I'm going to go to the website again here, download the notebook, and to my directory, examples in here. You should be able to reproduce. Okay, so download the notebook, then just open the notebook. Since we already installed the dependencies, so now it should just work just fine. So I'm going to run this one and then the second one, the third one. Okay, if you want to get the statistics, it's fine, you don't have to. Display tiles. So how many of you can see the map, the image here? Right, this should be no issue, right? You just download the book, you just run that. Everyone should be getting the same result. Yes? With that, now create a new code block after the map here. Okay? And as I mentioned earlier, you need to get this one. Basically, R, basically the response. So you ask the middleman to request the imagery and give me the tile URL. So if you want to see exactly what's in the response, just type R, Alt Enter. Can you see this one? Yes? So you see the URL is within the response. In the return is a dictionary. So how to actually get to the URL? It will be R and then square brackets, tiles, right? We don't get if you just do this one, you're gonna get a list. But we want to get to the URL. Right now the URL is the first item in the list. That's why we use this one 0. Make sense? Do you see this one now? With that, then we can create our map and then we can load the data. So I'm gonna create a new code block and I'm going to in here import GOS demo. Okay, and then you will be m equal to GOS demo.map and then display the map. This should be your own package. Okay, the name of your own package. And once you have that, just m.add tile layer, because this is the function that we added in the previous lecture. So all you need is just URL. Did I choose the name? Oh, you need to. You are welcome to use R equal to blah blah blah, but it's better to just assign that one to a variable. R tiles 0 to a variable name URL. Then we can just use the variable name directly here. So it'll be add tile layer. You're welcome to give it a name if you want to. I can just say GeoTief. Okay, and once you have that, you can zoom into the area here. You should see the map. That's simple. Anyone see the image? Yes? Raise your hand if you see the image on your map. Just one? I'm just adding 3 more lines, right? You should have your own package. The critical one is to get the URL. Once you have the URL, import your library, create a map, and then use map.add tile layer. Unless if you didn't have this function, then you cannot do that. You have to construct a tile layer. So if you didn't have, it will be something like this: ipylib map.tile layer, URL, name, attribution, and then just add layer. If you didn't have the function. Anyway, we need to move forward. So this is how you actually pull the data using the TiTiler and then display on the map. You might probably notice when we add the map, it's not automatically zoomed to the image area, right? It's actually just displayed on a global map. So it depends on the zoom. If your map is somewhere else, right? If you add a location like this, it's actually very difficult to see where is the image. Because earlier we used the volume, so we know like where is the location, but sometimes this will be very difficult. If your image is pretty tiny, you have no idea where it is. But if you go back to the example that I showed you earlier here, get code info. This is basically the bounding box. We can actually ask LeafMap to automatically zoom to the bounding box so that we don't have to, so the user don't have to figure out when you add the layer, it's going to automatically zoom to the bounding box. That would be pretty better, right? So you don't have to worry about that where it is, because sometimes you have no idea where it's actually located. So we can actually use this info because iPyLeaflet has a function called fit bounds, and that fit bounds can automatically zoom to the location. If you're not familiar, I can show you. You'll be iPyLeaflet, and you can Google it. I'm just going to go to the map, just to show you like what kind of things you need to provide in order to be able to fit to the bounding box. You'll be under the map and go to the map. So you can just Control F, fit bounds here. So this is the function you can ask the map to fit the bounding box, and the list need to be provided in the form southwest, northeast. So basically the lower left corner and the upper right corner is a list, and each corner itself is also a list. Okay, so this is actually what we want, but TiTiler also return a bounding box, but this bounding box is not the one we want. Okay, the format is different, so this can be quite confusing. Basically you have the data, but you need to reorganize it, otherwise it's not going to work. So remember, again, let's look at this one more time. You have two double brackets in here. So the lower left corner is a point, is a list. Upper right corner is a list. So south, southwest. So think about here. South, is south a latitude or longitude? Latitude, right? South, and then west, right? West, longitude. So it will be latitude, longitude, latitude, longitude. Remember? So if you look at this one here, it can be quite confusing, right? Earlier we said latitude, longitude, latitude, longitude. This one actually is longitude, latitude, longitude, latitude. So this is x mean, mean x, mean y, max x, max y. So it's kind of, you need to think about how you actually reorganize. So we need to rewrap that. So right now we have the bounding box, right? We have the bounds. If we come back to here, just show you like how do you reorganize that. So let me create a new code block here and bounds. You can print out. Oops, it's not take this long. It's probably stuck. So let me restart the kernel, and then one all the way to the end. So what we want is to reorganize this bounds variable, and then to get the info that we want. Okay, so now you see here, this is what we want. So we need to basically the new bounding box. So the south, let me tell you again, I'm confused now. Southwest, northeast. Okay, so which one is the south? Take a look at here. So this will be x mean, mean x, mean y, max x, max y. So this will be longitude, latitude, longitude, latitude. So what we're getting here, this will be the south, west, north, east. Okay, so basically reorganize that. How do we? I would say maybe bound box. Let me give you a new variable equal to. Oh, perfect. It's not right. This one is not right, so don't use it. Okay, so it'll be something like this, because it's going to be a list of two lists and then another list. Okay, now it looks perfect. So think about here, right? Leg long, leg long. So your new bounding box will be in a way like this. So bounds get this latitude, and the second one will be getting this longitude, and get this latitude, get this longitude. Now let's print out the bounding box. See that? And this is exactly in the format like this. Okay, southwest, northeast. Once we have that, now we can actually use the fit bounds function because we already have the bounding box. So take a look at here, right? Assume this is the map that we just created. We added the raster. Now we want the map to automatically zoom in to the location. So if we zoom in here, right? Perfect. But user have no idea if there's a small image. Can you really find the image on the global map? Very hard, right? But using the fit bounds function, we can automatically fit that. So now let's come back to here. m.fit bounding box. That's it. So let's come back to the map in here, right? It looks like this right now. And after I run the function, see where the map is located. So run it. Why is getting stuck every time? Not good. Yeah, then I need to restart again. Anyway, so let me run this one more time. And this is something you're going to run into all the time. So programming every package sometimes return the result differently. So you need to reorganize the data, restructure the data, so make sure that it's correct. If we run this one right now, again, look at the map. It's the global map. So hopefully it works this time. If I run it, right, finish. So come back to the map. How nice. It automatically zoom into the map. So now it doesn't matter where the image is located. It's always going to be able to zoom to the location, the map they added. Make sense? So with that, now we have a working example. This is how I test things, how I figure out how to add features in the package. I usually create a notebook and then use some sample examples, make sure everything works perfectly. Now I need to rethink about how to restructure and then make it a function. Yes?
Value error.
What?
It says not enough values to unpack. Expected to. I restarted it.
Where is it? Oh, you need to the square bracket here. You need another one here. Then 1 0 and then another bracket here. Another next. Yeah, try again. How nice.
Thank you.
So this is the area again, and I need to pay attention here. When you get the bounding box, so make sure there are 2 brackets. So one square bracket outside, and then southwest is also within a bracket. So basically you have 2 brackets. So this is the southwest corner. This is the northeast corner. So you need to make sure that you have a list of 2 lists inside. Otherwise, it's not going to work. So if you come back to the format here, 2 brackets, 1 bracket, comma, 1 bracket, and 2 brackets. All right. How many of you got this work? Okay, cool. So now you see you have a working example. Next step, how do we restructure and then add this one as a function to the package so that next time the user only needs to just provide a URL and then just add a function. They don't have to mess up the bounds, the stuff. You can build this in within a package. Okay, so next, this is where you really implement it. So open your modules and then probably go to the bottom of your package. Also, I would like to point out that if you're trying to add something to your map, make sure that it's under the map class. This function we added last time is outside the map class. Okay, so we want to have something inside the map class and indent, right? 1 tab indent. So once you're there, df, okay, and think about the name of the function you want to use. I can just df and then add maybe raster or something or code or something. Okay, it gives me some like autocomplete, but this is not what I want, so I have to be more specific about that. Okay, so what we can do, parentheses self, and then maybe URL. Okay, so I want the user to provide the URL. That's it. I can optionally provide some other parameters if I want to. For example, name. That's fine. I can provide a name equal to maybe raster, and maybe another parameter called fit bounds, because earlier I showed you how to automatically zoom to the image, but sometimes the user might look like that because if they want to keep the area, they already create a map, they already center a location, they don't want to do to fit bounds, you can turn it off. Okay, so we're going to provide the option called fit bounds equal to true. By default, the user are welcome to turn it off. Okay, and then kwargs, you probably need to remove all of those. Okay, so now we have this function definition. It's ready to go. So the next will be just to copy the source code from the for example, and then just restructure that. So let me show you how to do that. You come back to here. There are two component, queue essential components you need, right? So you need the TiTiler endpoint. The URL is going to be provided by the user, so we don't have to do that, but we do need this one. So we're going to copy the TiTiler endpoint, and then come back to the code here. Oops. Just paste it. Of course, you can also use the TiTiler endpoint as a parameters. For now, for simplification, we're just going to use this default one. Come back to here, and then the next will be this one. So I'm going to copy this one, get HTTPX. Oh, you need to also add the HTTPX. So for here, import HTTPX. Okay, so make sure they have all the dependencies. TiTiler endpoint, and come back to here, copy this portion, get the bounds, because later we want the user to automatically zoom to the bounds. So copy, and then hit enter, paste. Once you paste it, sometimes you have to indent it. So I'm going to indent here. Alright, so this is a TiTiler endpoint, the middleman. So the user is going to give me the URL, is going to return the bounding box, the bounds, right? Another one, it will be the second one here, go down. And this is another one we want, the GeoJSON, because we are getting the URL from this middleman. So Control C, come back to here. Okay. And then we're going to get the Thai URL, right? So if you remember earlier, you'll be the Thai, let's say just the Thai equal to R, something like this. Okay, see this coding block, what we're trying to do here, and this is the function, like the user provide me the URL, then I'm going to use the TiTiler to get the bounding box, so get the bounds. Also, I'm going to use the TiTiler endpoint to get the Thai URL, right? And with that, now we can just load the data onto the map, right? Because the tile here, this is the URL. We don't use the URL again because it's going to coincide with the variable name. So we use the Thai, just use the name called tile, should be fine. And with that, I can just self dot add tile layer. Perfect. Look at this one. So self means it's the map itself, right? So make sure when you have a function, every function if it is within a map class is always going to start with self and then comma, and this is the variable name, and this is add tile layer. So I'm going to put this one here one more time, make sure you can see this coding block, right? Not so complicated. So essentially there are two steps. First step, I'm going to get the bounding box, but later on we're going to fit to the bounds. Second one is to get the Thai URL, right? And these are the two components what this one is doing. So get the bounding box, get the Thai URL, and then get the tile, add the tile to the map. So the next step is to figure out whether you want to fit the bounding box or not. If you want, then we're going to fit the bounds. So again, we come back to this example we added earlier. how do we reorganize the bounding box? You'll be here like this one, right? Copy this one, come back here. Once you add the data layer, the next step is to decide whether you want to fit the bounds. So the fit bounds is a parameter by default equal to true. If the user turn it off, then we don't fit bounds. So here, if fit bounds, then I'm going to reorganize that into the bounding box, right? Bound box equal to this one, and then you'll be save.fit bounds. That's it. So I'm gonna pause here one more time, just let you see what the source code look like. And this will be the complete coding block for you to design a function that build on top of the example that we just went through, right? User just provide the URL, then I'm going to grab the bounding box. I'm going to get the Thai URL, and with that, I'm going to load the data onto the map so that the user don't have to like write this so many lines of code, because it can be quite tedious. Are you done with this? With that, now we can test the function. This is exactly what we want, how you build on top of other people's work and then simplify the source code. So let's test it, okay? Maybe I can create a new notebook rather than use the existing one. So I'm going to go to examples and then new notebooks, raster.ipynb. Okay, perfect. So what we need to do, same old procedure, create the map, define a variable, and then just call the function. So you'll be import GEOS demo, okay, hit enter, run, select the kernel. So the next step will be m equal to GEOS demo.map, okay, and then m. That's it. Next, we need to example, right? So we're going to use the same examples. What we can do is to use the same URL like this one. So I'm going to copy this open data, okay, and then paste the URL here, the same URL. Alt enter. Next, let's find out whether our function works or not, right? So we have added a function called m.add raster. So m.add raster. Perfect, right? It shows up. The URL is the only required parameter. That's it. So now pay attention to the map, right? See how the map is in action when I run this function. Okay? See it? Pay attention closely. Look at the screen. Run it. Boom. How nice it is. Now just one line of code, right? Much easier. User don't have to actually worry about where is the raster located. With that, now your function can work with any cloud optimized GeoTIFF, any HTTP URL. It doesn't matter where is that hosted. So this is just one example. I can add another one. So if you want, I can go to my find out some other example. So maybe go to the LeafMap website, for example. Not here anymore. So LeafMap, and go to the repo. I have some examples data set on GitHub. So it can also visit the data from the GitHub. It can be from anywhere. As long as you have a URL, HTTP URL, it should be able to handle that. So I'm going to go use the LeafMap examples, okay, and then data. I'm not sure if I have some data in here or not. It looks like I don't have the other data here. So I'm going to go to the OpenGOS. This is the one that I just created last week. I moved all my open source packages into here so that people can use whatever they want rather than under my personal account. If we go down to here, there's the data catalog. And I have some sample raster data set here. Okay, I'm going to pull the raster. And here's some data set in here. So now I can show you like how I can actually visualize that. So I'm going to click this HTTP in here. And keep in mind, don't copy this URL in the browser. It's not going to work, okay? This is not a direct URL. The function can only visualize the direct URL. What do I mean a direct URL? It means when I paste the URL in the browser, if I hit enter, it should pop up a download dialog box. If it doesn't, it is not a direct URL. Understand? So right now, for example, if I copy this URL, I will open the incognito mode. If I hit enter, if you open a website, it's the wrong URL. So make sure that you understand the differences. You will need to see this one. Raw, click the raw button, right click, and then copy the link URL. If you open this one more time, paste this URL, hit enter. It should pop out this one asking you to download. This is the right URL, otherwise wrong, okay? So with that, now they can test it. So I'm going to come back to my here, right? This is the previous one that I added. I can have another one called, create a new code block, URL2 equal to Control V, right? This is a raster on the internet. It's a cloud optimized GeoTIFF. Now I can use my package. So run this one, do the same thing, map.add raster URL. So pay attention to the map, okay? It's going to move, zoom to another location of the new image, okay? I'm going to run it. See that? How nice. Now you can handle any images. It doesn't matter where it's located. As long, basically, right now you are watching movie from anywhere. The movie can come from Netflix, can come from AWS, can come from plenty computer. All you need is just the URL. Now I can use this middleman, the TiTiler, to help you request the Thai URL, and then use the Thai URL to plot on the map. And in the meantime, you can also feed bounce. So let me do this one more time. Earlier we automatically used the feed bounce, but you don't necessarily have to. So if I run this one again, right, the map is going to move. Sometimes if you don't like that, you can turn it off. So here, I'm run this one again. Now I can turn the parameter feed mouse equal to false. Okay. So look at this map. It's not going to move because you don't want to jump around the map like all the time. So I can run this one. You see, it stays there. But the layer, the data layer should be already be added to the map. It's somewhere. Okay, it's here. It's actually added there. It's just not zoomed to the location. So similarly, I can add as many as you want. I can find another one. Maybe how about SRTM, right? Again, click the download button, copy the URL, and then come to here. Create a new code block, URL3 equal to this one. Alt enter, and then m.add raster, free bounce. And you might want to give a new name, otherwise sometimes you're going to be I'm not sure why it's keep stacking in here. Let me restart kernel, run it all. So after if we add this, the last raster will be the one that's centered around here. Oops. Oh, feed bound equal to false, and it's set to true, so that it's you see. This is the DM. It's not the color; is just a gray color. It doesn't look good. You can customize that. We don't have time to cover that today, but just let you know, you can visualize any raster dataset, a single band, multi-band, whatever you want. As long as you have the HTTP URL, now you should be able to plot it on the map without having to download it. Basically, this is how you stream the data, do the streaming of the data, and then shoot it on the map. So you can imagine you have some data on your server. You have the HTTP URL open to the public. Then you can develop some examples that allow users to pull the data, show it on the map, and overlay with other data layer. Of course, you can turn the data layer on and off. If you want to. Yes?
Can you just show the very last bit of that function?
Here? Yeah, I pushed this one to GitHub, so you're always welcome to use. Let me see here. And so the last step I'm going to show you is that inside your function, right? If you remember, we use the so-called HTTPX. This is a new dependency. So you need to make sure that you have this new dependency in your requirements.txt. Otherwise, when you build the package, this is not available. It's not going to work. Okay. So what you need to do, you go back to here and then requirements.txt and just add this one, HTTPX. Technically, it's not really necessary because this one is the same as the request, request, but it's a built-in library, so you don't need that. But if you want to keep it, just use this one. Make sure you add this one to your requirement.txt. Otherwise, it's not going to work. So here with that, now I can. Let me see here. Let me Control S and close this one. So I have the raster here. If you remember this one, let me restart my kernel one. And so I need to add the requirement.txt, also add the raster. So these are the 3 files I'm going to commit. And I can say add the raster function. Control Enter. Push. Okay, now I can open. You should better take a look. You can go to the my GitHub repo. So if you have a hard time, you can just copy and paste that one to your package. So what we did essentially just this function. So this is for adding the data from the internet and how you view that. You're welcome to develop notebook, and then so this is what, if you show you the div map here, notebooks, and click Jupyter Notebook number 3, code and stack, spatial temporal as a catalog. Exactly the same thing. So what I show you is just like that, right? Leaf map, URL, and then code, center, how many bands, tiles. Look at this one. Same idea. This is the URL that I show you here, right? I can add as many images as I want. Again, multiple data layers. So these are all from the max out open data, right? So you have some wire file. I want to show some map to my users that I load the file images before, after, right? It's pretty clear. So later on, you can also have a slider to slide the data layer left to the right, so they can compare the data layer if you want, right? So this is how you can do that pretty easy. Look at the source code of the div map and then think about how you can implement some of those. But these are the building blocks, essentially how you visualize raster data, how you visualize vector data, how you develop the sample first, and then convert it into the function, then create a notebook to test the function. If everything works out, then you can release the package. Right, so this is just one of those. You are welcome. For example, I maybe split control, something like this. You have different data layer, and this is another one like I mentioned earlier, right? I create a map. I have 2 image file. I can create a split map, and take a look at this. Right, one line of code. You just tell the user what URL you want to compare. Where are those 2 images? Now I can just use one line of code. You can compare the data layers all at once, right? So this is essentially just like you're watching 2 movies. One movie is Hollywood movie, was like 50 years ago. Now you have a new movie with the same name, and now you can compare side by side. One line of code, right? Pretty easy. Everything is open source, so you're welcome to look into the leaf map, see how the source code was constructed and how you can actually incorporate some of those into the package. Again, I have already built that. I'm just showing you how I build that. You're welcome to use div map as a dependency, but it's better to build something from scratch, build on top of other people's work, and then create the functions that you need. Okay, so that's pretty much about TiTiler, the middleman to help you. You can create your own middleman. Okay, we are just using the TiTiler endpoint. Next example I want to quickly show you is the so-called local Thai server. So this is another nice package. It's pretty new, probably 1 or 2 years ago they started. And it has also some pretty nice examples. They allow you to visualize data stored on your local computer because not everything is in the cloud. If you have some raster dataset on local computer, you want to visualize that using Python, this is the way to go. But you will need to install the package. So this is called local Thai server. If you have not done that, I'm going to here pip install, Control V, hit enter. So you do have to install this one. I'm not sure if it works on Windows or not, but at least on Linux computer it works just fine. Okay. Oh, yeah, looks like works nicely. So probably not. This is the tricky part. So GDAO, this is the package that can be quite challenging to install on Windows. Yeah, you fail. Okay, that's the problem. This is when you try to add some dependencies on your package. Sometimes you will run into issue like this because some packages you need to compile from the source code and you need a compiler. So if you don't have the correct compiler, it's going to fail. And this is where you need to use Conda or Mamba. That one usually you already built, so you don't have to build. So usually it will work just fine. I can just use Mamba install local Thai server and then C Conda first. Okay, this is usually how I install a package. But you always need to keep in mind, if you develop a function, develop something using this one, and if you include this dependency in your requirement.txt, people will not able to easily install it because they are going to download dependencies, they are going to install GDAO, and it doesn't work well on Windows. So Linux and Mac computers should probably fine, but this is going to be something you need to figure out. So what I usually do is that I don't include that dependency directly in the requirements of TXT. I have a function import the library within the function. So if the library doesn't exist, the user have to install that by themselves. And so what I can do here, let me quickly show you, right? Assume that I'm going to add another function. And df, I can maybe have a name called add local raster. Okay, and again you need to pass in the file name, self file name, for example file path whatever, and then the name equal to local raster, and then okay, so this is where you actually import the library. If the library doesn't exist, then you usually have to handle that. There's some other ways, but at least this one should, your package won't fail when you build the documentation website, otherwise you fail. So let me show you how you can do that. I can just say try and then import local Thai server. It might be the same thing, just like Raster IO. That package might also run into the same issue. So, and then from here, except import error, perfect, right? Control S. So we are adding this function, and this function is going to use the local Thai server. We're going to say except import error. The import error means if the user doesn't have this package on a local computer, it's going to fail. Okay. Then I can come back to install this one. So I'm going to use the Mamba. Oops. Oh, Mamba is not installed yet. So it's going to take some time to install. But let me show you, like, if you really want to have GDAO on your computer, you can do that as well. So you can use pip to install. I'm going to use leaf map. So I'm going to show you where is the secret, how you install it without having to run into the compile error. So go to the diff map and then go to the GitHub and GitHub workflows, and this is where actually it's being built. So you can click, for example, the Ubuntu. So within there, I actually install GDAO. and that one is like it will swap across platform. So this is actually the line used to install. By default, if you pip install GTiler, it's going to install from the official one. That one needs a compiler, it doesn't work. But we can use this one, find links, no case. So basically we're downloading from somewhere else. And then because somebody else already built the package for us. So what we can do, I can copy this one, come here, open the terminal, paste, hit enter. This one should work just fine. You can think about this is much easier because it already compiled. It should download, install. Building wheel, I hope it's successful. Otherwise, you will need to use Mamba for that. Oops. Yeah, it doesn't work. Then we have no choice. You have to use Mamba. Usually on Linux or Mac computer, it's pretty easy. So this is a tricky issue that you have to figure out. And if you want, you can go to the workflow, for example, and then take a look at Windows. So this is actually how I build that. You see a conda install, GTiler, blah blah. So if it doesn't work, and then I can come back to here. It should work. It's going to take some time, so it's not ideal because if you're trying to build a package that's going to work across platform, you have to think about the dependency. If there's a dependency that's going to have some trouble install on a certain platform, think twice before you add it into the requirements.txt, because when people use pip install your package, if it fail on your Windows, it will fail on other Windows. So this is how you think about how do I do that. You either let the user handle by themselves, or if you really want to do that, you need to make sure that the package can install properly. So there are lots of dependencies, especially Geospatial, GTiler, Raster, IO, that kind of stuff. It's challenging. So again, one recommended way would be to import this one. You test it on local computer because you use the conda. But when user actually call the function, at least you tell the user that the package need to be installed, and you tell them how they actually going to install. You can point them to the website if needed. We don't have time to finish this today. We will continue on Thursday just to show you quickly how you handle this issue. Or simply just look at leaf map and see how this is being handled within the leaf map package. So if you go to maybe quickly show you the leaf map website, and there's a function API reference leaf map. There should be one called add raster or add local tile something. Add local tile. And if you scroll down, kind of similar, but how you add the local raster. Well, we'll continue that on Thursday, but that's all we have today. So make sure you practice and at least get the example how to visualize image from the internet and show it on the map, automatically zoom to the bounding box. Then you are good to go. Okay, I will see you on Thursday.